Today's lesson is on polynomials. A polynomial is just an algebraic expression with different terms consisting of numbers, variables, and only positive exponents. So here is an example of a polynomial. 2x squared plus 3x minus 5. So it's an algebraic expression. It has numbers, it has variables, it has different terms, and it only has a positive exponent. So an example of an expression that is not a polynomial would be 3x to the power of negative 2 plus 4. It has a negative exponent. Or if you have 4 over x plus 2, that is also not a polynomial, because when the variable is in the denominator, that technically means it has a negative exponent. So these are not polynomials. Let's go back to 2x squared plus 3x minus 5. Some key words that I will be using: coefficient, constant, and terms. A coefficient is just referring to the numbers in front of the variables. The word term is just the combination of a coefficient and a variable separated by an addition or subtraction sign. So this polynomial has 3 terms. And then the constant is always the number that is last, the number that does not have a variable. Now, each polynomial has a different classification or a name, and we name the polynomials based on its exponents and number of terms. So let's first talk about the exponents, which this is also called the degree. And the degree is referring to the highest exponent that the polynomial has. So we're going to look at when it has a degree of 1, or 0, 1, 2, 3, and then 4 or more. If the highest exponent in the polynomial is 0, it is called a constant, and that would look like, let's say you just have 5x to the power of 0. Well, that really just equals 5, which is a number without a variable. So if the highest exponent is 0, it is simply called a constant. If the highest exponent is 1, we would call that linear. An example, 2x. Because exponent 1, we don't always write it. You can, but you don't need to. And that would be an example of linear. If the highest exponent is 2, it is called a quadratic. An example of that would be 4x squared. When the highest exponent is 3, we call that a cubic polynomial. And anything more than that, we will just say it's a 4th degree polynomial, or a 5th degree, or a 6th degree, 7th degree, and so on. So 10x to the 4th. Now all these examples that I gave you are polynomials that just have one term. They're called monomials. So now we have to look at how the name also changes depending on how the number of terms change. Alright, so number of terms, so maybe 1 term, 2 terms, 3 terms, 4 terms, and so on. When there's only one term, it's called a monomial. So an example would be 6x to the 3rd. The highest exponent is 3, and there's only one term, so it's called a cubic monomial. When there are 2 terms, we would call it a binomial. And in this example, 4x squared plus 3, highest exponent 2, which means it's quadratic, so it's a quadratic binomial. If the polynomial has 3 terms, we call that a trinomial, and this has the highest exponent 4, so it's a 4th degree trinomial. And now anything that is 4 terms or more, we just simply call a polynomial. So technically all of these are polynomials, but we have more specific ones: monomial, binomial, and trinomial. So a polynomial, let's say it is like a fourth degree one, could be 6x to the fifth minus 2x squared plus 3x minus 7. That would be a fifth degree polynomial. So for the next part of the lesson, we're going to practice writing polynomials in standard form and then classifying them or naming them. So writing them in standard form simply just means you are writing them so that exponents are in decreasing order. And then once they're in decreasing order, we're going to classify them based on their degree and number of terms. So for the first example, we have 4x minus 3x squared. To write them in standard form, exponents need to be in decreasing order. 4x technically means it has exponent 1, so we need to write negative 3x squared first, and then a positive 4x second. So it's now in standard form. Now we need to name it. Highest exponent is 2, so that means quadratic, and it has 2 terms, so it's a binomial. It's a quadratic binomial. Alright, so this one, c squared, has exponent 2. 2 is a constant, which technically means it has exponent 0. And then c has exponent 1, so I'm going to rewrite this in standard form. C squared, and then positive plus 4c, and then minus 2 at the end. Highest exponent is 2, so it's a quadratic, but it has 3 terms, so it's a quadratic trinomial. Okay, in example 3, we have 2x plus 3x. Now, this is a special example because 2x and 3x, they are like terms because they have the same exponent. So you first want to combine them. That together equals 5x, which has highest exponent of 1, and it's only one term, so it is a linear monomial. So here is the last example: negative x plus 2x squared plus 3x to the third minus 7. I want you to try this on your own, so pause the video and write it in standard form and then classify it. So you should have gotten 3x to the third plus 2x squared minus x minus 7. And that is a cubic polynomial. Alright, so now we are going to practice adding and subtracting polynomials. And it's pretty easy. All you're thinking about doing is combining like terms. So you combine when they have the same variable and the same exponent. And we just got done with a unit with all the properties of exponents, and we're constantly adding or subtracting exponents. But when we are adding polynomials and just combining like terms, you do not change the exponents. So here are 2 separate polynomials that we're going to add together. And the parentheses are there just to separate the 2 different polynomials. However, they do not need to be there. We're not distributing anything. We're not multiplying. We are just combining like terms. So 4x squared, we're going to add with 2x squared. Add the coefficients to see how many x squareds you have. So add the coefficients. 4 plus 2 is 6. Exponents don't change. We're just counting how many x squareds do you have. 6x squared. And now 6x, its like term is negative 9x. So 6 plus negative 9 is negative 3, negative 3x. And then we have a positive 7. You add the constants together, plus 1. 7 plus 1 is 8. And that is it, 6x squared minus 3x plus 8. And that is a quadratic trinomial. Here's our second example, a squared plus a plus 1 plus the polynomial negative a plus 5a squared plus 20. So just notice that the second polynomial is not given to you in standard form. So you just have to be careful when you are combining like terms and just make sure your answer is always in standard form. So a squared doesn't necessarily match up with the first term, it matches up with the term that has the same exponent. So a squared plus 5a squared, add the coefficients. Coefficient here is 1, so 5 plus 1 is 6, 6a squared. And then if we have a, its like term is the negative 8a, so 1 plus negative 8 is negative 7a, and then add the constants. 1 plus 20 is 21. Alright, so now we are subtracting polynomials, and it's the same idea that we're combining like terms, but there's an extra step when we have to subtract. So our two polynomials, 2x to the third plus 5x squared minus 3x, and then we're subtracting x to the third minus 8x squared plus 11. And what we need to do is if you're subtracting, you have to think that you're subtracting each of those terms. So an easy way to do this is think about distributing the subtraction sign as a negative sign to all the terms in the second polynomial. So now we can rewrite this 2x to the third plus 5x squared minus 3x, and now rewrite the second polynomial after you distribute. So minus x to the third, negative times a negative becomes plus 8x squared, and then when you distribute the negative to the positive 11, it is now minus 11. So after you distribute, now combine like terms, 2x squared, or 2x to the third, and then take the sign in front, minus x to the third is 1x to the third. And now 5x squared, take the sign in front, plus 8x squared is 13x squared. And then, let's see, negative 3x. There are no other terms with that exponent, so minus 3x comes down, and then a negative 11. There are no other constants, so that will just fall down. So here we have a cubic polynomial as our final answer written in standard form. Alright, so here's our last example with our first lesson on polynomials, subtracting. The first step is we just need to distribute the subtraction sign as a negative to everything inside the second polynomial. First polynomial we can just rewrite 6w squared minus 3w plus 1, and then this turns into minus w squared minus w, and then negative times a negative, it would be plus 9. So now we can combine like terms, 6w squared, and then here's our other w squared, take the sign in front. So 6 plus negative 1 would be 5w squared. And now negative 3w plus a negative w would be negative 4w, and a positive 1 plus 9 is 10. So here we have a quadratic trinomial as our final answer written in standard form. So there's your full lesson, kind of an introduction to polynomials, how to name them, write them in standard form, and then add and subtract them. Easy peasy, lemon squeezy. Good luck!